In this segment, we're going to talk about value models. First, let's take a step back and consider a perspective called the design value loop perspective. In this one, we're going to start off by using our values to define our problem, propose our different alternatives, which then defines our design space, and then we need to evaluate this design space in order to come up with a possible solution. Now, in evaluating our design space, we may need to use models and simulations to generate data. Now, it turns out that the models that we're using are not just those that generate the evaluation data, but also how we interpret that evaluation data. These are called value models. The purpose of a value model is to, in a structured way, interpret the evaluated data. That is, how do we consider, for example, miles per gallon, price, comfort, styling, reliability, all the different criteria that we care about in terms of picking what is considered best. Value models are often done explicitly, though sometimes they could be implicit. Implicit value models we keep in our heads. The danger with using implicit value models is that they may be subject to biases, they may change over time, and they may result in unpredictable or unexplainable results. By making value models explicit, it helps to foster conversation around what our actual interpretations of these valuative metrics are, and allows us an opportunity to overcome our own cognitive biases. Now, returning to the value loop perspective, it turns out we care about more than just the design space and the evaluation data. We care about three principal sets of data. We care about the resource data, that is all the costs incurred for realizing one of these designs. We may care about performance data, things like, for example, miles per gallon, revisit time for our satellite system, and so forth. We also care about how we interpret these metrics. We call that value data. Different value metrics that we're going to either explicitly or implicitly generate using our value models. And so now looking at these three spaces of data, we actually have three different categories of models that are used to generate them. The first are called cost models. The purpose of cost models is to generate our resource data. The purpose of performance models is to generate our performance data. And the purpose of our value models is to generate our value data. In this segment, we're going to focus on the value models. At a high level, value can be thought of as addressing three core concepts. 1, degree of satisfaction or benefit. 2, resources used or cost. And 3, the degree of importance or priority. Value in a very general sense is the balancing of these three things. Now, sometimes value is operationalized as benefit at cost. And clearly this is subjective and context dependent. For example, what's the value of a heated seat in a car when you're in a Maine winter versus a Florida summer? If I only live in Maine, then I'm going to judge a car with heated seats very differently than if I only live in Florida. Now, it's important to recognize that values are always used, even if they're not made explicit. There's a fallacy in thinking that there is an objectively right answer to these decision problems. In the decision analysis community, there's a debate between basic versus articulated values. This describes whether we can decompose a problem into a set of criteria or if we have to holistically judge the goodness of alternatives. The consequence of this for our purposes is that a basics value frame means that we can decompose our problem into a set of metrics that can be evaluated using models. Now, quantitative models allow us to generate evidence that could then be pointed to in trying to predict the goodness of alternatives. Now, the danger is that if a particular stakeholder requires an articulated values frame, that is, they can only judgment the goodness of alternative when considering it holistically, it makes it very challenging to develop a quantitative model to predict the goodness of these alternatives. Now, there's another consideration that we must take into account when looking at theories of choice. That is, normative versus descriptive. A normative value model tells us how we should make decisions, whereas a descriptive value model describes how we do make decisions. For our purposes, we care about prescriptive value models. That is, models that help us make better decisions. They're based on rigorous theory, but allow for the realities of a messy decision-making environment. Now, in a realistic engineering environment, oftentimes the stakeholders or customers we wish to satisfy are not present during key decisions. In order to increase the likelihood that we're creating value for these stakeholders, using value models as proxies can be useful. One thing that we have to be careful about is a false sense of security around using quantitative techniques. There's a fallacy that subjectivity is a bad thing, that having objective measures results in a better solution. It turns out there's no such thing as a purely objective measure. We're using judgment in determining what measures to use. When we develop requirements for our systems, these are a form of a value statement. Using numbers does not always make something objective. We can put a numeric scale on subjective measures, such as how satisfied I am. Now, judgment always enters engineering design, and it's important to recognize this so that we can control for it and have explicit conversations. Now, there are two main types of value models that we're going to consider. One are single criteria value models, which try to predict how stakeholders interpret goodness on different levels of a scale, and multi-criteria value models, which transform sets of criteria into a single measure of goodness, or interpretation of how satisfied a stakeholder might be. Now, value models could also be deterministic, that is, outcomes are certain, or take uncertainty into account. In the decision analysis literature, the former are often called value functions, while the latter are called utility functions. For the purposes of this course, we will refer to any model that tries to predict benefit at cost as a value model, irrespective of how it treats uncertainty. Now, there are many different types of value models that exist, both single and multi-criteria, including things like net present value, discounted cash flow, cost-benefit analysis, single attribute and multi-attribute utilities, analytic hierarchy process, and so forth. A number of these are described in more detail in the supplemental material that follows.